Today we are going to extend the plastic analysis to multi-story and multi-bay frames. Let us consider a simple two-story single bay frame under the action of horizontal and vertical loads as shown. Let it be symmetric in the beginning. Let us now identify the possible hinge locations, which are the locations where bending moments they are maximum. So these 6 locations can easily be identified. However, at the joints which are at the first floor level, the situation is different. Now at these joints there are 3 members and the bending moments will be different. So there are 3 possible locations or 3 possible hinges at these 2 joints. So the situation is different from, say, the topmost beam column joint, where for example the beam and column members which are meeting, they have the same bending moment. So the hinge will be formed at either of the 2, but it will be considered as hinge in the joint. But in the case of these first floor joints, there are 3 independent hinges which could appear in the 2 columns or the beam. Let us now speculate on the possible mechanisms. So here is the first possible mechanism, the beam mechanism at the first floor level. And then we have the second mechanism, similar mechanism, but this would involve the beam at the second floor level. So note that these 2 mechanisms, they are involving essentially a local zone of the structure to fail, not essentially leading to the collapse of the entire structure. Then the third mechanism could be sway mechanism, and in this case also there are 2 possibilities. One possibility is that sway might happen to the second story as we are showing here. So that forms the mechanism number 3. The other possibility is that this kind of sway mechanism happens with the ground story, that is similar to the soft story failure in the case of buildings under seismic forces. So that is the 4th independent mechanism. So we have formulated 4 out of the 6 mechanisms. Now the question is, what will be the 5th and the 6th mechanisms? Here the 5th and the 6th mechanisms will be a bit unconventional. They are called as joint mechanisms. So these mechanisms would essentially involve the failure of the entire joint there are two critical joints in this category, the joints where three members are meeting at the first floor level. If they undergo complete failure, then this also represents a mechanism as is shown here. This is a very special situation that plastic hinges have formed in all the members meeting at that particular joint, and that joint has undergone some rotation, and that represents the mechanism kind of failure. So mechanism 5 involves this kind of failure of the left joint, and mechanism number 6 similarly involves the failure of the right joint. So each of them are independent mechanisms in themselves. Now the next task is to formulate combined mechanisms. There is no hard and fast rule here. We have 6 independent mechanisms, so there can be a large number of combinations possible. So we follow here an approach that will combine 2 mechanisms and we'll get a resultant combined mechanism. After that, we will utilize the resultant mechanism as the base for the next combined mechanism. We will superimpose some other mechanism to that and reach to a new mechanism. So this process will be continued till we are satisfied. So here we are basically superimposing mechanism number 1, which is the beam mechanism involving the first floor beam, with the sway mechanism involving the ground floor, that is mechanism number 4, and this gives rise to the combined mechanism as shown here. So please note the location of the various hinges, especially at the first floor left joint, how the hinges are shown in the beams and the columns. So this is now our mechanism number 7. Now we will use this as the base and we'll get the next mechanism by superimposing this mechanism with joint mechanism, that is mechanism number 5. Basically this involves imparting a clockwise rotation to the concerned joint. So basically this process will eliminate or cancel 2 hinges. So it does produce a new hinge also, but on the net, the virtual work done, the internal virtual work done is reduced. That's why this mechanism is likely to result in lesser ultimate load as compared to mechanism number 7. Let us now superimpose this mechanism number 8 with mechanism number 3, that is the second story sway, and this will result in mechanism number 9 as shown below. Pay careful attention to how the various hinges they appear at various joints, especially at the right joint situated at first floor level. Now, taking a cue from the previous steps, we can very easily identify that there is a possibility of combining this mechanism with the second joint mechanism, that is mechanism number 6, because we can see that this process will eliminate hinges. It will definitely create one additional hinge, but it will also eliminate 2 more hinges. So we do that. Finally, we arrive at mechanism number 11 by superimposing the last combined mechanism number 10 with mechanism 2, which is basically the beam mechanism involving the second floor beam. Now let's zoom to the region at the second floor level, the left and the right joints. So apparently at both the locations there appear to be two hinges, one in the beam and one in the column. Now these two members, they are meeting at the joint. So under the limiting condition that these distances they tend to 0, the two hinges will merge, and this will result in hinge cancellation in the left joint, and in the right joint it will not lead to hinge cancellation, but there will be some rotation. So that may be understood here. So the resultant effect is being shown here now. So by this kind of process we have evolved at a total number of 11 possible mechanisms, which include 6 fundamental mechanisms are the independent mechanisms. Now is it possible to have more combined mechanisms? Yes, it is definitely possible. But let's just take a pause here and find out the final collapse load for each of these mechanisms. Then identify the lowest load. Corresponding to that load, check the yield and equilibrium criteria. If the yield and the equilibrium criteria are satisfied, that means we have identified the correct mechanism. If they are not satisfied, that means we must now work further and try to find more possible mechanisms. After our experience with two-story single bay frame, we can now do the process for single story two bay frame. So here if we find out what are the possible hinge locations, we can very easily identify them based on our experience with the previous example. But now note that in the middle first floor joint there will be 3 possible hinge locations. The reasons are same as for the case of the previous frame, and here if we now do the calculations, the resultant comes out to be 4. So 4 independent mechanisms are there. So what are those 4 independent mechanisms? Let us have a look. The most obvious mechanism would be beam mechanism. Now here there are 2 possibilities. There are 2 beams at the first floor. So any one of them undergoing the mechanism formation would represent the possible mechanism. So here we are showing mechanism number 1 involving the left beam, and now we are showing mechanism number 2 involving the right beam. The next possible mechanism shall be the sway mechanism. So here, since the structure is only single story, so all the 3 columns will be involved, each with 2 hinges. Finally, what is the 4th mechanism? So our experience shows that the 4th mechanism will be the joint mechanism, that is the mechanism involving rotation of the middle first floor joint, because that involves 3 members. So if it undergoes rotation like this such that hinges develop in each of the 3 members, then this is a valid failure mechanism. Now we can start formulating combined mechanisms. So we follow the same approach, that we will combine 2 independent mechanisms first, that is mechanism number 1 and mechanism number 3, that is the beam mechanism with the sway mechanism, and we will get a new combined mechanism number 5. Thereafter we will use this mechanism as the base and superimpose something else and get a new mechanism. So this process will be carried out. So now see here what is the final shape the structure assumes after this combination. So this is mechanism number 5. Please pay careful attention to the hinges which are being marked at the top of the columns. So some hinges will get cancelled out and some new hinges will appear. Now we superimpose this last mechanism with mechanism number 2, that is the second beam mechanism, and this gives us mechanism number 6. So as before, the top rightmost joint apparently has 2 hinges in the beam as well as the column, but we can just merge the 2 into a single one as shown here, and we'll get the resultant final profile like this one. Now what more mechanism could be possible? Now a closer look at the mid top joint immediately gives us intuition that we can make use of the joint mechanism, because that will lead to hinge cancellation. So we perform that operation here and we get a new mechanism number 7. This process leads to cancellation of two hinges. So are more mechanisms possible? Yes, they are definitely possible. But let's first analyze these 7 mechanisms, find out the lowest of the ultimate failure load and check that particular mechanism for yield and equilibrium criteria. Based on our solving these two problems, one involving two-story single bay frame and other involving single story two bay frame, we can pen down following observations. Number 1, as the number of stories and the bays they increase in the frame, the computational effort becomes manifold. We can see that if we just increase only one story or one bay, the numbers they grow very large as compared to the single story or single bay frame. The plastic analysis becomes more and more tedious as we keep adding the number of bays and the stories. Also, unlike the matrix stiffness approach, here it's not possible to develop a single software or some kind of code using MATLAB or any other programming platform which can do plastic analysis of any generalized structure. So because of these reasons, plastic analysis is currently limited to simple structures only. So thank you very much.